should be good to go. All right, today we're covering weight and balance. Here's the plan. We'll start with an introduction. We'll get into weight and balance, and we'll cover a little bit of flight planning. If you have any questions throughout, just go ahead and ask them. But then if at the end, we'll have a Q&A, and you can ask questions there. First, let's talk about who I am. My name is Monty. I'm a flight instructor, and my objective is to help you earn your wings. Let's get straight into weight and balance. The objective of this discussion is this. The student should develop knowledge of the elements related to weight and balance and have the ability to properly calculate an airplane's weight and balance for the given situation. Now, the key elements we're going to cover here, if nothing else, these are the three I want you to take away. First of all, performance. How does weight and balance affect our performance? How to calculate weight and balance, and then what happens if you add, remove, or shift your weight. Now, here are the elements. We'll start with some terms. We'll get into weight and flight performance, weight and structure, stability and controllability, weight and balance and control, and then determining weight and balance. Now, here are some terms. Let's start with this glossary, and then we'll move on. First of all, the reference datum is the imaginary line from which all measurements of the arm are taken. So if we have an aircraft here, and look at my beautiful airplane. All right. Some airplanes will measure from the nose cone, from the tip of the nose cone to a position, let's say the seat, and they'll say, all right, this arm or this distance from this reference point is 75 inches or whatever. Some aircraft will use the firewall or some other reference line. That's what that refers to. Now, the arm is the distance from that reference line to the center of gravity of an object on the aircraft. So, for example, if we're taking the center of gravity of the pilot, they might take that reference point and say the arm is 75 inches or whatever. Now, the station, that's the location in the aircraft identified by a number designating distance from the datum. Now, moment is the weight times the arm it's the weight times that arm. So if we are talking about weight in terms of pounds and that arm in terms of inches, your moment is going to be in terms of, or in units of pound inches. So if you ever are doing calculations, it's always a good idea to label your units so that at the end, your units all make sense. Your center of gravity should be in terms of inches by the end of the calculations. Now, the moment index, this is the moment divided by a constant such as 100 or 1,000, just to make the numbers a little easier to work with. Instead of dealing with like hundreds of thousands pound inches, we just divide it by 100 or 1,000. The center of gravity is the point at which an airplane would balance if suspended at that point. The CG limits, if we have an aircraft, look at that beautiful airplane. The CG limits are the points at which you don't want your center of gravity to go too far forward or too far aft. The basic empty weight, that's the weight of the airplane, optional equipment, unusable fuel, and full fluids. The unusable fuel is the fuel in the tanks that cannot be safely used in flight or drained on the ground. Max takeoff or landing weight, that's the greatest weight allowed for takeoff and landing. Max ramp weight is the total permitted weight of a loaded aircraft, including all fuel. And max zero fuel weight, the maximum allowable weight, exclusive of usable fuel. The payload is the weight of the occupants, cargo, and baggage. If you think like a spaceship, the payload is the stuff that you're taking up into space. The useful load is the basic empty weight subtracted from the maximum allowable gross weight. And here are some standard weights that you should have memorized. Fuel is 6 pounds per gallon. Jet fuel is 6.8 pounds. Oil is 7.5 pounds. And water is 8.35 pounds. The biggest one that I recommend memorizing is this one. All right, now that we're done with those terms, not fun to just define stuff. Let's actually get into some stuff. Let's talk about weight and flight performance. Now, the reason we don't want to take off with an overloaded aircraft is because it will be very difficult to rotate, climb out, and fly with an aircraft that is too heavy. There's a point at which the aircraft is just too heavy to fly. So we don't want to overload the aircraft. Now, heavier gross weights are going to result in a higher takeoff speed and a longer takeoff run. Reduce your rate and angle of climb, lower maximum altitude, and slower cruise speed, range, and increase fuel consumption. It's also going to be less maneuverable, and you're going to have a higher stall speed, which means you're going to stall earlier than you'd expect. You're also going to have a higher approach speed and a longer landing roll because of your inertia, and then you're going to put a lot of excessive weight on your nose and or tail gear. So taking off heavy is inadvisable. Right now, if you overload the aircraft, that will significantly degrade your performance, just like taking off heavy, but now overloading it. And then you can also overstress the aircraft or overheat the engine. Now, remember, your flight performance degrades at higher weights and may not be possible to fly if you are overloaded. So make sure to do your weight and balance calculations to ensure the aircraft is safe to fly. Yeah, here are some categories. The normal category is you should be able to pull negative 1.52 to 3.8 G. If the aircraft is in the utility category, it should be able to pull between negative 1.76 G to 4.4 G. And then the acrobatic category, negative 3 to 6 Gs. Now, if you overload the aircraft, you won't, you'll see when we look at our weight and balance envelope, if you are too heavy, then you will leave the utility category and go into the normal category. So your loading will dictate how much of a load you can put on the aircraft. Now, always, of course, follow your manufacturer's guidelines. Let's talk about stability and controllability. Now, the more forward your CG is, if you just imagine where the balance point is on the aircraft, if it's to the front of the aircraft, your aircraft will feel heavier. It'll be difficult to pull your nose up and rotate off the ground. It will be more controllable in a stall as opposed to an aft CG, which will in turn feel lighter and will have a faster plane with a forward with a forward CG. Now, an aircraft with an aft CG might be difficult to recover from a stall or a spin, so keep that in mind. And that's, again, why we always want to do our weight and balance and verify that our center of gravity is within our min and max loading. And we talked about how in the past, actually, we talked about this last week, how stability is greatly affected by your center of gravity. An aircraft that is not balanced will be not as easy. It will be more difficult to control than it will be less stable, than an aircraft that is balanced. Let's see. Yeah, let's move on here. Actually, I'm just going to bypass all this. This is a wall of text, and let's just talk about actually doing the calculations. Now, like we said before, your weight is going to be in pounds typically. Your arm is going to be in inches. And again, that arm is from some reference point on the aircraft. In this case, we're modeling our aircraft as a fulcrum. And whenever we do these calculations, we're going to use the fulcrum point as our equal point. And it's just a mathematical equation at this point. You've got your weight, 50 pounds, multiplied by your arm, which is 100 inches. And so you've got 50 times 100, and that comes out to 5,000 pound inches. That is your moment. Now, if we want to balance the fulcrum, or if we want to balance the aircraft, everything should come out to zero. The left side of the equation, or the left side of the fulcrum, should equal in the same moment as the right side of the fulcrum. The right side of the fulcrum. So when we do these calculations, it'll be, we'll put our equal sign here underneath the fulcrum. We'll say 50 pounds times its arm of 50 inches, plus 100 pounds times its arm of 25 inches. And they come out to a total of a moment of 5,000 pound inches. And now if we go to the right side of the fulcrum, we've got a 50 pound weight here and a 100 pound arm. Multiply that together, it comes out to 5,000 pound inches, and it is balanced, which is great. That's what we want to see. Now, sometimes the FAA will ask you, well, actually, let's back up a little bit. Before we talk about balancing the equation, before we haven't really taken into account the weight of the aircraft or the weight of the plank. Whenever we do, we don't really care about the total length of the plank. We care about its center of gravity and the distance from the reference point. In this case, this is a 90-inch long plank or aircraft, but its center of gravity is 15 inches aft or to the right of the fulcrum. So for our calculations, it will be 200 pounds times 15 inches. So to balance this equation, now let's talk about where we're going to put things. The question might be, where would you put this 500-pound weight to balance the system? And so you don't know the distance here, so we're going to call that a variable x. And it's a simple mathematical equation. 500 pounds times some distance, and there's nothing else on this side, is equal to this 250-pound object here, 250 times 20 inches, plus the weight of the aircraft or the plank, 200 pounds times 15 inches, And with a little algebra, it comes out to 16 inches. You guys are all college level, so I assume you can do basic algebra. If you want, we can actually just run through it. Basically, what is this? 5,000 plus, what was that? 3,000? Comes out to 8,000 divided by 500, comes out to 16 inches. And again, verify all your units. Your center of gravity should be in terms of inches. Actually, let's do one last thing. Whenever we're doing our calculations in the actual aircraft, we're going to take the sum of the weights, which will be in terms of pounds, and we're going to take the sum of the moments, which will be in terms of pound inches. And at the end of the whole deal, we're going to take the sum of the moments divided by the sum of the weights, which will be pound inches divided by pounds. And of course, the pounds will cross out, and you'll be left with a distance. And that distance is your center of gravity. And we'll use a chart in the Pilot Operating Handbook to verify that we are within our weight and balance, and we're within our weight and balance thing. Let's do this. So, taking the page out of the Pilot Operating Handbook, this is a loading arrangement. Let's say your pilot is 190 pounds. The arm, we're just going to use 37 inches. 37 inches. By the way, the empty weight and the moment are given to you in the weight and balance data card. Let's say your passengers are a nice dainty 120 pounds and 73 inches for that arm. And then the baggage, let's put bags here in the baggage area A, we'll say 95 inches. So baggage, let's say we put 20 pounds in the baggage at 95 inches. And then fuel, let's say we're flying with 25 gallons. 25 gallons. Now remember, we have to convert gallons to pounds. So 25 gallons times 6 pounds per gallon comes out to 150 pounds. And here, the usable fuel is at 48 inches. 48 inches. So now let's do some math. The weight and the arm and the moment for the aircraft are done. The pilot is 190 times, what was that, 37? Comes out to 7,030. Passenger 120 times 73 comes out to 8,760. The bags at 20 pounds come to 95, comes out to 1,900. And then the fuel, 150 pounds times 48 inches, comes out to 7,200. And again, these are all in pound inches, these are in pounds, and these are in inches, right? And so now we're going to take the sum or the total of both of these two columns. So the weight, 1642 plus 190 plus 120 plus 20 plus 150 comes out to 2,122 pounds. And our moment, 626,000 plus 7030 plus 8760 plus 1,900 plus 7,200 comes out to a total moment of 650,890 pound inches. Now, again, we're going to take that moment. I'm going to switch back to white here. 650,890 pound inches divided by our total weight, which is 2,122 pounds. Our pounds will cross out and we'll be left with a unit of inches divided by 22? Yeah. Is that right? 650,890 divided by 2122. Oh, I must have screwed something up. Hang on. I'm left with 306 inches, which means I screwed up somewhere. Let's verify this. 1642. One second. Yeah. Oh, I think I had one too many zeros here. That's why. All right, there we go. 62600 plus 7030 plus 8760 plus 1900 plus 7200 comes out to 87. Is that right? I screwed up somewhere. Well, that's embarrassing. Anyways, you get the idea. You get some value in inches, and then you're going to confirm here, our weight is 2122, which is about here. And then our center of gravity, 2122. Yeah, there we go. That's what I did.
Monty, should I be seeing your screen right now?
Yeah, do you guys not see my screen?
No.
Oh my gosh. See, that's why. Oh, that's embarrassing. How about now?
Yes.
There we go. Sweet. All right. One second. Let me get this back up here. Oh, that's embarrassing. Well, good thing I was recording the screen the entire time, so we'll be able to go review, and you can see my errors. All right, so let's do that again, right? All right, weight, arm, and there's one fewer zero here. That's the mistake I made. Just a typo there. So let's say the pilot was what, 190 times 37. Passengers was 120 times 73. Bags were 20 pounds at 95 inches, and fuel was 25 pounds times 6 pounds per gallon at 48 inches. Solid. There we go. 190 times 37 comes out to 7,030. 120 times 73 comes out to 8,760. 20 times 95 comes out to 1,900. And 25 times 6 pounds per gallon times 48 inches comes out to 7,200. And so we add up all the weights. 1642 plus 190 plus 120 plus 20 plus 25 times 6 comes out to 2122 pounds. And our moment, 62600, right? 7030 plus 8760 plus 1900 plus 7200 comes out to a total moment of 87,490 pound inches. And now, since I fixed that, 87490 pound inches divided by 2122 pounds. Pounds cross out. And it comes out to a center of gravity of 41.22 inches. So that is saying that our center of gravity is 41 inches from some reference point on the aircraft. And now we're going to use the next page here, the center of gravity limits, to determine whether or not our aircraft is within weight and balance limitations. So at 2122, 2,122 pounds, somewhere over here. And then our center of gravity, 41 inches, about here. So we are in the normal category. So our aircraft would be safe to fly. And of course, we want to be careful and not pull too many Gs. Referring back to this one, our normal category would be up to 3.8 G. So we can't be doing, 4.4 Gs. We can't be doing aerobatics in this aircraft. Yeah. Man, I'm bummed out you guys couldn't see my screen until now. Oh, geez. That's my mistake. I should have had that squared away. Okay, so another way to do this same calculation is using these center of gravity graphs. I'm not a huge fan of them, to be honest with you, but they might show up on the knowledge exam, so it's a good idea to go study them. So first, they're going to give you the empty weight of the aircraft and its moment. In this case, it has been divided by 1,000. So moment time divided by 1,000. So that's why the numbers are going to be a little smaller. The pilot and front seat passenger, 400 pounds. We're going to find this graph here, this loading graph. We've got the load moment on the x-axis and the weight on the y-axis. And we're just going to find the category we need, pilot and front passenger, and we're going to write it up to its weight, 400 pounds right here. And then our moment is going to be 15, right? And we do the same thing with baggage, 120. We find the baggage and go up to 120. We get a moment of 11.5? Yeah. Fuel at 38 gallons. We're going to ride this up to 38 gallons and then get a moment of, 11. And then oil. The oil is in the notes here. 8 quarts, 15 pounds at negative 0.2 moment. Now, what does that mean? Why would it have a negative moment? Well, it's because the reference point is here, and everything aft of that reference point we label as positive, and anything forward of that reference point we label as negative, because to balance it, we'd have to move it to this side of the equation and call it a negative 0.2. And that's why that's negative. Anyways, like before, we take the sum of the weights and the sum of the moments, comes out to 2113 and a moment of 88.8. In this case, we're not looking at a center of gravity graph now. Now we're looking at a weight versus moment graph. So instead of dividing the moments by the weights, we're just going to leave it as is, and then find our weight, 2113, somewhere over here, and our moment, 85, 88-ish, somewhere like right there. So we, again, are in our normal category, and we're safe to fly. Within weight, within balance, and we're good to go. Now, another way you might see this problem is in these center of gravity tables. The idea is the same. You find your weight, you find the arms. In this case, the arms are going to be listed at the top of each column. For example, the baggage arm is 140 inches. The pilot arm is 85. Rear seats, 121. Fuel tank, 75. And then auxiliary fuel tank is 94. And here, again, instead of dividing your moments by your weights to find, your center of gravity, in this chart, you're going to find the weights and the moments and determine whether or not it's within your limits. For example, if your total weight is 2,500 pounds, your minimum moment or your center of gravity is has to be within these two here, right? Your minimum moment is 1,932 and your maximum is 2,143. So as long as your moment is balanced somewhere between these two at this weight, then you are safe to fly. If not, you need to rebalance the aircraft. Either add some ballast or remove things out of the aircraft or shift things around. And on the exam, they'll give you a couple of options. And the best way to do it is, calculate your center of gravity or calculate your weight and your moment, and then systematically approach it and, determine which of the options is the right way to go. All right, so that kind of covers our weight and balance discussion. What are your questions at this time?
I do not have any questions currently.
Awesome. Sounds good. We'll move on. All right, so let's talk real quick about making a flight plan from Bellingham to, Fairchild, I think. So like before, last week we did a flight plan from Payne to Bellingham, and we went a bit more in depth into our Northwest craft checklist. And again, just to review, that stands for NOTAMs, weather, known delays, runways, alternates, fuel, and takeoff and landing distance calculations. Now, your NOTAMs and weather can be found through 1-800-WEATHER BRIEF or ForeFlight or Garmin Pilot to verify that there are no NOTAMs that in your way that might preclude you from flying and that the weather is safe for you to fly. My recommendation is go practice filing flight plans or getting weather briefs every day if you can, just to get comfortable interpreting your weather. Known delays are also important. Go determine whether or not there are any delays in your area. And then runway distance. We're going to cover how to find that today. Alternates and fuel. Remember the fuel, we need plus 30 minutes. So we need to be able to get to our point, first landing point, and then loiter at cruise speed for 30 minutes in the day. And then at night, we need 45 minutes. And then our takeoff and landing distance calculations, those are done through our pilot operating handbook. And of course, if you want to go more in depth, you can go review that video that we made last week. This week, we're going to cover route selection. So first of all, our route, if we just go straight from Bellingham to Fairchild, it's a straight shot, 208 degrees, 56 nautical miles. Now, looking at this, yeah, I guess you could theoretically just go straight there. Is it the safest route? Not really. My recommendation, or the way that I would fly this, would be to do something like this. Fly to stay over land as much as possible, because the aircraft that we fly have, are land-based or land aircraft. And we don't want to spend too much time flying over large bodies of water with passengers. So I would do something like this. Maybe not this exact route. Maybe you could go, Skagit to Jefferson or whatever. But I would do Bellingham to Whidbey Island to Jefferson, and then to Fairchild. And this puts us over land for a good portion of our route and has some pretty good visual checkpoints. Point Wilson here. We got Eliza Island, and of course, the giant runway here over Whidbey. And you might be able to see some cool F-18s. Now, let's talk about some airspace stuff here. At Bellingham, we are in the Class Delta airspace, so we'll need to talk to the tower before we depart. We'll listen to ATIS for the weather information. We'll request to depart to the south, and once they clear us, we will be able to leave. And once we're out of the Delta, we don't need to talk to anybody else until we are, again, back in this magenta circle, which is the Charlie or Class Charlie airspace. Before you get into the Class Charlie airspace, you need to hear your call sign. If they acknowledge you, then you are allowed to enter. If not, then you need to stay clear. Now, in both Delta and Charlie airspace, the weather minimums are 3152. That means we need 3 miles of visibility. You need 500 feet. You need to stay clear by 500 feet below, 1,000 feet above, and then 2,000 feet of horizontal separation between you and the clouds. So 3152. Right? Both in the Delta and the Charlie. To enter the Charlie, you have to establish radio communications. That's your call sign. And then as you leave the Charlie, they'll likely cancel flight following and tell you to squawk VFR once you're there, once you're clear. Now, over Jefferson, we're going to be in the Class Echo, depending on what altitude you're at. Again, Class Echo up to 10,000 feet is going to be the same visibility requirements, 3152. And then as you come west to Fairchild, this airspace here is going to be Echo all the way down to the surface. Now, the difference between this airspace and, let's say, Jefferson airspace is that this magenta dash circle tells you that the airspace at the surface is Echo, which is controlled, all the way up to the next category of airspace, which in this case would be Class A, Alpha airspace. Now, the airspace over Jefferson is Class Golf at the surface until you get to 700 feet above the ground, and then it becomes Echo. Now, the reason is because of this magenta vignette here. And at the surface, if you were to depart Jefferson, you would need 3 miles visibility, 1 mile visibility and clear of clouds. All you need is 1 mile visibility and clear of clouds in the daytime to depart out of Jefferson. And that's because it's in Class G, Class Golf airspace. And then moving further west, 10 miles before we get to Fairchild, we would start making our radio calls to announce our position and enter the pattern. Now let's talk about our airport diagram. Anytime you're taxiing on the surface, you want to have an airport diagram or a map of the airport out on an e-board so you know where you're going and you understand what your route is and any instructions the tower might give you. Let's start from the very top here. The top says this is an airport diagram for Bellingham International Airport. Our radio communications are here. We've got the ATIS, that's our weather frequency, 134.45. The tower is 124.9, and ground control is 127.4. So before we talk to ground, we're going to get our weather information. Before we taxi, we're going to get permission to taxi via ground. And then as we're waiting to depart, we will get permission to depart through tower 124.9. And they'll say something like Cessna 3 Echo, runway 16 clear for takeoff. And you reply 16 clear for takeoff, 3 Echo, and depart. Bam. Some things to note here, an HS, brown HS like this, that's a hotspot. It's just a very congested area. You want to be careful taxiing there. And then these areas are not observed, or they are not visible from the tower. So be careful in this area too, right here and here. Now this right here tells us the angular difference between true north and magnetic north. That's always worth knowing. And then the control tower position and the FBO or the fixed base operator and transient parking. This is a big one, by the way. When you go to a new airfield, always look for where to park. Where's transient parking? It can be kind of confusing. And that's something that I've noticed a lot of schools kind of fail to do or fail to teach. They'll just be like, yeah, go do a touch and go at that one airport and come back. And you get your private pilot and you're like, oh, shoot, now what do I do? Like, where do I park? Right? It's at transient parking. That's where you go. Cool. And then this is for Fairchild. Again, you want to study this before you depart. It's right here. Let's see here, the runways, runway information, what direction the pattern's in, right traffic for runway 26, it looks like. Runway 1331, there are trees on the end of the runway, and it is right traffic for runway 31. Fuel, lighting, airport remarks. This is all really important stuff to know. If you want to get in contact with the airport manager, that's a good phone number to have. Radio frequencies, approach, clearance delivery, the type of airspace, like I said, class Echo, and the NOTAMs. Let's see, radio aids navigation. So these are like VOR or navigational radios and stuff. So there's that. So study this. This is in your chart supplement. So you've got the chart, the paper map, and then the chart supplement gives you additional information that would be difficult to display for every airport in a neat little book. So there's that. Yeah, so that kind of covers what I wanted to talk about today. What are your questions at this time? And again, I'm sorry I didn't have my screen shared when we started. I feel bad about that.
I still do not have questions currently.
Cool. Awesome. Well, I appreciate you coming. Is there anybody else here? Or is just you?
It's just me.
Just you. Sweet. Awesome, man. Well, thanks. I appreciate you coming to hang out. If you do have questions, you can feel free to shoot me a DM or give me a text.
Sounds good.
Awesome. Take care.